In the critical strip, the eta function converges. But the eta function, odd eta function, and subordinate eta function can be obtained from the binomial theorem of the eta function. The subordinate eta functions 6, 1 and 6, 5 can be represented again as the subordinate zeta function of mod 12. The subordinate eta function 6, 1 is equal to the subordinate zeta function 12, 1 minus subordinate zeta function 12, 7, and the subordinate eta function 6, 5 is equal to the subordinate zeta function 12, 5 minus subordinate zeta function 12, 11. The sum of the subordinate eta functions 6, 1 and 6, 5 is equal to the L function chi1 of mod 12, and the difference between the subordinate eta functions 6, 1 and 6, 5 is equal to the L function chi3 of mod 12. Therefore, the non-trivial zero of the L function of mod 12 by the sum and difference of the subordinate eta functions 6, 1 and 6, 5 also exists on the critical line. If the red subordinate eta function 6, 1 and the blue subordinate 6, 5 are symmetrical to the origin, they are non-trivial zeros of the L function chi1 of mod 12. Also, when the red subordinate eta function 6, 1 and the blue subordinate eta function 6, 5 meet, they are non-trivial zeros of the L function chi3 of mod 12. Just as the sum and difference of the subordinate eta functions 4, 1 and 4, 3 is the L function of mod 8, the sum and difference of the subordinate eta functions 6, 1 and 6, 5 is also the L function of mod 12. But the sum and difference of the subordinate eta functions 3, 1 and 3, 2 are represented as the eta function and the L functions of mod 3 and mod 6. Considering that the non-trivial zeros of the extended L functions possible by the subordinate eta function also exist on the critical line, the generalized Riemann hypothesis must include the extended L function of the eta function. In addition, the extended L function of the eta function is also related to the problem of finding the value of the subordinate eta function at s equals 1. The zeta function diverges due to the pole at s equals 1, but the eta function converges. If the L function of s equals 1 can be found, the subordinate eta function of s equals 1 can be found. The binomial theorem of the eta function can only find the convergence value of the subordinate eta function for s equals 1, and the exact value must be found by the L function.